Good morning, good afternoon, and good evening, everybody, and welcome to another episode of Loosely Coupled by Bridging the Gap. My name is Karol Skrzynowski, and I'll be your host tonight. And, well, coffee. Coffee as always. Tonight, we're having a comeback to the show, and we're going to be talking about the differences between data architecture and integration architecture, because apparently that's the biggest problem in getting to understand each other is in jargon between those two actual fields. At least that's my perspective. Don't blame me. I'm an integration architect. For this particular purpose, today we're having a data architect with us just to talk about the jargon instead of talking about architecture per se. So, welcome to the show. Welcome back, Andrew Jones.
Hello, thank you for having me back.
Yeah, always happy to. Andrew, for those who have not seen the previous episode where we were discussing pretty much the same topic, right? Data architecture versus integration architecture, but in context of other things like data mesh, etc. Could you please introduce yourself? Tell everybody a little bit about you. What drives you as an architect? Where are you coming from in terms of that data architecture field?
Yeah, so I currently work for a company called LocalStack. Joined there quite recently as a staff data engineer, and there I'm building a data platform. And really, building data platforms or building platforms in general is what I've done for most of my career. Initially with software engineering platforms, and now data platforms the last sort of 15 years or so. And as part of that, I think a lot about how the platform can enable other teams around the company, how it can
Mm-hmm.
encourage good quality data, good governance of data, good management of data. And it was through a lot of that I ended up writing this book about data contracts, which helped us manage a lot of that as well, which came out a few years ago. So that's what really excites me: platforms, contracts, integrations, interfaces, those kind of things.
So pretty much half of this is also my scope of work in that sense. Well, to some extent at least. Um, I at least I don't know about you, but I tend to love that as an architect, even though I specialize in integration specifically, I tend to wear all sorts of different hats along the way on projects. Sometimes it's a hat of a business analyst, other times it's a hat of a solution architect. In another sense, it's sometimes also a hat of a data architect, although completely unwillingly. But jokes aside, data architecture without integration architecture without proper data architecture in place is just literally pushing data sometimes without a reason. It's like really tedious work to that extent, right?
Mm.
If we have governance and all these things in place, and data architecture and integration architecture works in tandem, then it makes a lot of sense, and we have really smooth sailing in all sorts of projects. But that requires a lot of things. And today we're not going to be talking about those things. We're going to be talking about the terms we're using, because like it was last stream, we had so many minor conflicts about just not understanding each other using a specific term. So today we're diving into those just for the fun of it. And for all you watching, we actually sat down before the stream over what was that, 2 weeks or so? We were like in the spreadsheet on a Google Drive, we were like dropping different terms into that spreadsheet. What comes to mind? What did we ask our colleagues? What might be relevant for that, etc. So that we actually could discuss those. But as we discussed just before the stream, I think we can go through some sort of a software development lifecycle so that we put them at least in some sort of a cohesive order of how they occur in natural world. Well, natural, you know. Does that sound good?
Yeah, sounds
Should we
great.
do that?
Let's do it.
All right. So the usual is, I believe, that we start with a project. It's starting always with an idea, right? So we have some sort of a business idea. Somebody validates that. We have a business analyst figuring, okay, that's feasible. That's a good idea. There's market for it, or whatever else we're doing. There's always that business driver, business reason, right? At this point anywhere in the project lifecycle, software development lifecycle, do you already come in as an architect?
I like to. I don't always.
Ah!
come in. Often the data requirements don't get fed into that idea. But
Hmm.
I would like to see data involved there. If not me or someone like me being involved directly, then I would like to see at least the idea, the document proposing this idea cover things like, well, how is this going to change how we structure data, how we're going to use data that's produced by this project to help us achieve a goal, how we're going to measure KPIs, all those kind of things. So
Hmm.
I would like to see data come in there, but quite often data isn't brought in at this stage, and it's more of an afterthought much later in the life cycle where the thing's almost built, and then you're like, oh, actually, yeah, we also need some reporting, and now let's talk to the data guys and girls and let them figure it out. So
And fix
ideally,
our world.
yeah, it's like we're just making all these changes and we're doing it next week. Can you get everything ready? It's like, well, um, but yeah, ideally we would be involved in that stage.
Okay. From my perspective as an integration architect, we're also involved always too late for the most part. Uh, I always love to be involved at the level of business analysis where we actually are looking what the business processes are. Because at this stage, I'm looking like, oh, what are the interactions between different entities, different systems? Because I look at the BPMN diagram or discuss the BPMN diagram in the meeting in the forum. It's like, oh, here we have an integration, here we have an integration, this is an integration, etc. So we're looking at those BPMNs, and they gave us all sorts of information. And this is where I usually would start. Would, if I could. That's the premise, right? So uh, I think both of our fields are neglected about the same way in that sense. Involvement of projects, and we are asked later just to fix the world the mess that they created. So uh, I think a good thing is to define for a lot of people what exactly is integration architecture, what exactly is data architecture, because I think that's the key here, because these are two different fields, but I believe that they're very related to one another because one cannot exist without another to an extent. Well, in the modern distributed world of computing, that is impossible, in my opinion, right? So,
Mhm.
from that perspective, what is your definition of integration architecture? I'm not asking about your field, but
You try and catch me out.
yeah, let's go.
Spicy. Well, I think
Now I'm
integration
taking notes.
architecture. Yeah, yeah, it's a test me later. Um, integration architecture, I think it's mostly around well how different systems talk to each other and basically send in data to each other, how they make calls to each other to take actions,
Mhm.
um, so that they can work together to produce an outcome that's greater than the sum of their parts. So the architecture, integration architecture, is about how they do that. What methods do you support to allow these things to talk to each other? Um, do you have particular standards you want to enforce there? Particular governance, maybe? Um, yeah, something like that. How does that sound as a definition?
Pretty good, pretty good. On top of that, the all how I add okay standards, but that involves integration patterns for moving the
Mhm.
data else here and there. That involves security. That involves all sorts of policies around throttling data, data traffic. That involves also understanding where data is originating from, where it needs to reside, and then when it is relevant, because integrations can be triggered in a multitude of ways. As we know, but basically there are three base types of communication. That being synchronous calls, like on-demand instant feedback, async calls, which is basically any event notification command can be also async, etc. And then we have batch processing. All of those have different triggers and different set of behaviors. So, from integration architecture perspective, we're always looking at the behavior of the systems, how they are, and you spot on how they interact with one another, how they want to talk to each other, or how can they talk to each other, because sometimes they can't. That's also a thing. If we deal with very old legacy systems, sometimes they're constrained by lack of staff, lack of knowledge, etc. So then we're having a problem.
Mhm.
So pretty good, pretty good. Pretty,
Thanks.
you did your homework.
7 out of 10.
Right. So now I probably should answer the other question the other way around. What is, in my view, data architecture? And I
Mhm.
did my homework as well. So if I'm looking at data architecture, uh, this is understanding, first of all, understanding where data originates from, where it resides, where it's needed. Then what the data is precise. So we're looking at semantics of data to figure out what do we have, what's the use of that data, where can we use it when where it's applicable, and then of course, lastly, when it's applicable, because when is a very important question here, because sometimes we need data instantly, real time. Sometimes we need data on demand. Sometimes we don't need data for a month, and then for example, batch processing comes in. So the when, dictated by a solution and dictated by data architecture of the use of data, right? Is that these are the core questions that data architects usually answer for me, and then I add to that how. But from my perspective, that's not limited to this. It's also all sorts of governance. It's data quality. It's tracking lineage of data, especially the more distributed the systems are, the more important it is, especially in high security environments where you need to have audit logs of everything, then that data lineage is important. And well, lastly, is the even more important now is data products, and then that relates to data meshing and actually understanding the products we have in the organization, that is data. And productized data is something I completely don't understand, but I get the gist that we can make it a product. Does that sound about right?
Yeah, yeah, that's about right as well. And I
And this
think,
is where my knowledge ends.
and with in
Joking.
data architecture, like where you spend most of your time will depend on the different companies you're working in and the kind of data you're dealing with. So, for example,
Yeah,
you might end up becoming quite an expert in data regulation because you're handling a lot of personal data, or you might end up thinking a lot about how we secure financial data if you're working in a bank or financial institution.
yeah.
So, a lot of that we're thinking about how we store data at rest as well, how we encrypt it, how we give it right access. So, all things under governance, which you mentioned, but yeah, there's potentially quite a lot more there as well, depending on where you're working and the environment you're working in.
And to that extent, this also goes into the field of integration architecture, because data is also considered at rest and in transit, right?
Mm-hmm.
So if we have data at rest, I usually tell, hey, data at rest is none of my concern. That's for all the systems to figure out, because I don't have data at rest in an integration platform.
Mm-hmm.
But data in transit is all I do. That literally all that I do, and also then governing that data in transit is a concern of data architecture. And this is where the overlap, from my perspective, is the biggest overlap of data architecture and integration architecture, because we also need to understand how data is moved.
Mm-hmm. Yeah, you
Now,
might get the requirements from a data architect, maybe because they might know more about some of the requirements, the regulatory requirements, or the requirements from a data protection officer, who we might spend more time with than you might. But you need, so sometimes the data architect might be the sort of person who can translate those more regulatory requirements that they spend their day and night in to be kind of your concerns, which is like, okay, well, how much do I need to encrypt if it's in while it's in transit, and what keys I use, how often do I rotate, and those kind of, yeah, the how, like you said, how do I do this in
yeah.
practice?
Now, here we already, I think, stumble into the first thing that trips up a lot of people, because we're talking about moving data. I think the data architecture term is data movement, and the integration architecture term is application integration. or system integration, right? Uh, Correct me if I'm wrong, but I believe these terms mean exactly the same thing: moving data from one place to another based on some sort of a business reason of processing, right?
Yeah, yeah, exactly. Because often with data, you are having to move data around. Not always. Sometimes you can get away with more sort of synchronous or async communication, but it normally is this batch processing that you mentioned earlier. And we're thinking about how we can move data from one system to another system or database that is better suited for the analytical workloads that will be carried out upon them. So yeah, data movement is where I spend a lot of time in data architecture.
But that's a subset of data architecture, not the whole thing in that sense. And then the specialization would be integration architecture that helps deal with data movement, right?
Yeah, exactly.
Okay. That said, now, uh, because I said the lovely word integration, you know where I'm going, right?
I think so.
Yeah. So the story I tell people in terms of complete lack of understanding and the problems, exactly the jargon problems that we're having. I literally had a manager, not my direct manager, luckily, but manager in the company I worked for, that did not understand that there is a difference between application integration and data integration. Because both of them had the word integration in it, he thought that this is exactly the same. So this resulted in a very obscure and funny scenario. Funny from the perspective of time. At that time, it was absolutely not funny. It was horrendous. That that manager figured that building an integration platform, that the database developers would be great people to build an integration platform to move data. You can probably imagine how this ended up being, right? So what they actually built was an MDM solution with a NoSQL heavily stateful database covered around with Azure functions feeding data in and out. Of course, that is not a integration platform. That was literally an MDM, right? They were creating golden records and redistributing them to whomever was interested. Now, if we agree that application integration is the aspect of moving data between specific domain systems, then in that sense, what is the definition of data integration?
Yeah, it's a good question. I've seen those examples as well before in the past. Unfortunately, it keeps happening. But I think that what data integration, I think there's a definition that has been historically correct in that it is quite different. But I think these days it's becoming more similar to application integration. So I think
Oh,
historically, data integration has generally been about sort of grabbing data from source systems and putting it into somewhere centralized in a data warehouse or data lake or something like that. But like I mentioned at the start briefly, that my background was in software engineering, and I think I've always thought there isn't really so much different between, or there shouldn't be such a big difference between data integration and application integration. They're both, the how is slightly different, like maybe more batchy, maybe more moving data and storing it at rest somewhere else. But I would like to see there being more similarities between the two. I would like to see better interfaces between the two,
hmm,
and I would like to see change management on those schemas. And I would like to see contracts and SLOs on the data, and all the sort of things you would get if you're integrating systems. If, for example, like if you've got a sort of microservices or something similar
hmm,
architecture where you're doing a lot of integrations internally, a lot of the requirements you have for that integration, I think, should be similar to data, similar for your data integration too. So
interesting.
yeah, I don't know if I would say the data integration definition should be that different to application integration. I think historically it has been, but I think we're moving away from that to saying it's a lot more similar.
Oh, that's an interesting twist because from my working understanding of data integration, I say it usually say it's very different, and it's very different because of course, data integration will have aspects of application integration in it, but data integration, even as I just typed it into Google right now, just for the sake of checking what Google will say about that,
Mhm.
and it says it's the process of combining data from different sources into one single view, right? So, in my understanding of data integration is always, oh, this is the process of that creating that golden record, that unified view that is, tailored view from snippets of data from other places, cleaning them up, and then presenting them as a unified view, as a standardized, cohesive per object, right? So kind of like that master data management aspect, right? And then, of course, you have that data from various sources. So you need to do application integration. So you need to integrate those sources and the MDM or whatever place that you're processing said data together, so that the data flows to that place where you're doing data integration. And that's always been my view, and that view also stems from the aspect of that, yeah, notion of having centralized systems like MDM systems or BI systems that just siphon in data from everywhere to have them centrally and then work on that data, right? Uh, and then I always say that this is the problem definition wise is not the problem there. The problem is with technology, because we have integration technologies, middleware that has been there for 3 decades now, and we have data technology for working with data. Middleware never had data capabilities, or when it has limited data capabilities. So sometimes vendors started adding that data capabilities to it. So, for example, operational middleware started having ETL capabilities all of a sudden. And then data not products, data software uh, didn't have application integration capabilities. So vendors started adding ingestion pipelines, ways to integrate with other systems to do that system integration, application integration, so that you can actually ingest that data and not rely on a third party. And this is for me, in that sense, where the majority of the confusion originates from, that we had those capabilities very clean at the beginning, but because one data software product needed to be supplied with data, so they, instead of relying on another product, they just figured, oh, we're gonna add functions to actually siphon data out of a database, etc. Hence, that application integration aspect started showing up with this kind of software. That's at least my view. And then, of course, you have the processes of extract, transform, and load. And ETL processes always had ETL processes, not ELT processes. That's the difference, right?
Mhm.
ETL processes already had that business logic of transforming data for whatever is the purpose. So that was in the pipeline. It was transformed to land already, I don't know, pre-cleaned, pre something in the source, in the target system.
Yeah. Yeah, so when I answered the question, I was mainly focusing on the actual integration, so right on the kind of left side. But you're right, typically, again, I think this is changing, but
Mhm.
a lot of the data integration would end up trying to build a centralized, joined up view of a whole business that could then serve any business question once it's been transformed and cleaned up, like you said.
Mhm.
And again, that's still how many people do it. That's still the end goal for many organizations, is to build a centralized data warehouse that will take all the data from all over business, that's all dirty, all different formats, and then try to bring it all and make a perfect representation of it later. But again, that's something that I think is changing in at least a couple of ways. One is moving away from not always being centralized and to more decentralized architectures where you're not having one centralized, similar to the MDM problem, where you try to fit everything into one database and have that being the source of truth. It often doesn't end up becoming a source of truth. It ends up becoming another source of truth.
Yeah,
Same for data warehouses, is they often try to become a source of truth, but never quite achieve it because it's just too complicated. So why don't we just have domains own their source of truth for their domain, which is a smaller problem to manage, and then present that to other domains. And the ability, as long as you've got the ability to carry on joining that data later, then you can still answer the same questions, but you don't have one team trying to own data from across the whole company and try and make sense of it. That's a very difficult problem.
Yeah.
And I think the other way it's changing is this assumption that you always have to get in raw, dirty data and then clean it up. And that's a source of pain and confusion and expense for a lot of data engineering teams because you spend all your time trying to clean up this data, and as soon as you do it, something else breaks. Some of the assumptions you've made in your ETL breaks because something changed upstream, and you're constantly
Yeah.
firefighting. So I think again that's nothing we're trying to push a bit more left and say, well, actually, why don't you provide the data that meets the business requirements so that whether it's a centralized data team or another data team or another domain or another service or an AI agent or whatever it might be, they can get the same context and create the same results from the data without having another team do all the cleaning first, removing that as a bottleneck. So, yeah, I think things are changing quite a lot in data architecture, particularly well at many companies. There's many companies that are not changing. Obviously, it's going to take a while, but I think a lot of companies are moving in this direction because they're seeing the cost of the data cleanup and the data transformation work. They're seeing the outcomes not that good in terms of the reliability and quality of the data and how it actually answers questions and whether we get a return on investment on these huge centralized teams and data warehouses they created. And the data is being used for more and more important things than it was before. It wasn't just analytics, which I think is still important, but now it's using the same data to power product features, or whether directly or through via AI and ML. So
Hmm.
I think both that increasing requirements from the output of data has led to more of a change in how we see data integration and data architecture and learning more from application integration and application and integration architecture there and bringing a lot of those same lessons over to data architecture to allow more federation, more flexibility, fewer bottlenecks, and
Right.
better level of results at the end.
So you're absolutely spot on here because that's my observation as well, that the world has moved away from centralized into distributed, very much so, which changes very little for me specifically as an integration architect because that was my world all over. But it changes a lot for data architects because we're no longer looking at a centralized pillar of the source of truth being in one place, holistic view, because people realize that's just impossible.
Mm-hmm.
Like 20 years ago, people realized that canonical data models are impossible to maintain at scale. This is probably analogous problem space. A centralized data warehouse with one source of truth is not maintainable at scale, not feasible to do at scale, right? At a
Mm-hmm.
small scale, yes. At the big scale of a whole company, the bigger the company, the less feasible it is. And I've seen like from my example, those guys were really struggling at a certain point after a few years of building that integration platform. Uh,
Mm-hmm.
70% of the workload that they did a week was operations, not development.
Yeah.
That kind of says a lot about this struggle. But you said something very that I'm looking at our list of terms, and I think the term that you dropped there somewhere, not specifically, but the term that relates is shift left.
Mm-hmm.
This is a term that I have no idea what it means because it doesn't exist in integration architecture. So, would you mind just explaining what's that shift left?
Sure. So the term shift left has been used from various different areas in software engineering and security and data over the last 10, 15 years or so. So you can imagine sort of say 15 years ago when you were doing software engineering then, a lot of companies were still, you had a software engineering team, then you hand it off to a QA team, and then you had a testing team and a deployment team, and it's all kind of like a supply chain of code going through different systems, different people before you can actually be released. And to try to speed up software development, you try to do some things sooner. Because the problem was if you've discovered an issue towards the right of that chain, say QA found a problem, a bug, or security found a security issue after QA, and then you have to get that back to software development. It's quite a long cycle going back and forth, and you're not delivering code, you're not shipping anything while this is happening. So it's a long cycle. It's also quite expensive to fix because that software team has moved on to other things. Now I've got to stop and fix it, and it's holding up other features. So they're like, well, what if we could shift that discovery of security problems, that discovery of testing issues? What if we could do that left when the code is being written? So as a software engineer, I write code, I run some automated tests, and then I've created a security issue. I see it straight away before I commit code, before I send code off to another team. I can then fix it right now while I'm still coding, and it's the cheapest place to do it. It hasn't been shipped, it hasn't been released, nothing's happened, and I can fix it straight away. And by shifting that left, you're reducing costs, you're increasing velocity. So that's where shift left originally came from. When it comes to data and data architecture and data integration, we've adopted that same terminology of shift left. It's slightly different because it's not so much in the software development lifecycle. But that's not necessarily true. We can potentially put more things in the software development lifecycle to prevent issues from leaving the software engineer's local machine and being deployed to production and then causing issues downstream later. So in data architecture, one of the biggest problems we have is a change is made upstream, it gets deployed to a service upstream, but maybe the next morning after the data processing runs overnight, suddenly everything breaks because that changed the schema. Or even worse, nothing broke, but actually the meaning of the data changed, and now all the reports are wrong, and memory numbers have doubled, and no one really knows why, and was it correct yesterday or today? And and then that's expensive. Finding that out on the right, like your CFO opens their dashboard on a Monday morning and sees revenue numbers are doubled, and they're like, well, why are they doubled? Let me go and ask the data team. I don't know. Let me go and do some investigation. And by the end of the day, they realise it's a change upstream, and now we've got to get a software engineering team to revert that change. Probably too late by then, so now I have to put workarounds in ETL. You're looking at a couple of days where the numbers are all wrong. That's expensive. A lot of people involved. Takes a long time and a bad outcome as well for the user of data.
Okay, so
if that left, be cheaper.
So in that sense, it's a shift left on the timeline of where we're doing certain things, so that we, in that sense, we bake in quality assurance earlier in the process of software development lifecycle. Right?
Yeah, exactly.
Okay. So now that you explained this, I actually looking at this from a design perspective of the interaction design between systems. I actually also apply shift left. Never named it this way. Never used this phrase. Yeah, but basically, if I'm looking at proposing interactions between systems, I always look at where the data originates from, and then who is then supposed to deal with the business logic of said data. Where is that place? So the business logic usually should be in the first relevant place where the data is either originates from or used in a specific context, because these are not always the same place. So that if we're designing, we're always designing so that any heavy logic is as close to the place where the data resides.
Yeah.
So for example, if I have data in one system, and I'm querying that data, so all the operations on getting that query and preparing that data should be in that system, not extorted out into the integration platform or to the system calling. because that means that if the system, the consuming system, is now suddenly orchestrating calls through the integration platform, point-to-point calls, to gather that data and then combine it into something meaningful, that means that first of all, in the source, the APIs are completely designed wrong and they're crud, most likely. And then we're burning money on meaningless interactions through an integration platform, which provide very little um, value. And then we're pushing all the logical work to the consuming system, which is the system. Well, in domain-driven design, this would be the system on the right, because the downstream is also in DDD is always on the right for some reason. So that is again the shift to left in terms of as early as possible provide something that is meaningful, and this applies also to designing integrations between systems. That as early as possible we want an API or somebody pushing something to the integration platform that has actual tangible meaning and it's actionable on the other side.
Mhm. Exactly. So you see this
But
just as best practice. It's about obviously how you design things. But if
yeah,
you look at how data integration has been designed historically, it's exactly
mhm.
the opposite of that. It's what you described as what you want to avoid, where all logic is being applied very late in a process, and therefore it's quite expensive, and any small change upstream has massive implications downstream on that logic. So in some ways we're behind in data integration, and we're just starting to think about this. And don't want to develop the podcast too much by going into the history of why it's this way, but I think you can see if you go. I, I, I also don't want to keep plugging my book, but in my first chapter of my book is trying to work out how we end up in this state of building things in this way. And it's really a lot of it is just how historically we've been doing data integration, starting from sort of old sort of on-prem databases that had certain characteristics, which meant you had to suck data out, you had to not do too much work on the database because it had so much capacity and so much computing, you couldn't scale it, and it was very expensive. And you have to do it somewhere later where it's cheaper. And we carry that pattern through to present day. Better tooling, no need to do it that way today. We just did it because that's how we always did it. But now
Unfortunate.
yeah, it's unfortunate, but now we are realizing what you already know is that actually it's very costly to do that here. So we come up with this term called shift left to try to explain the differences. But as you say, from many other areas of software engineering, it's obvious.
Yeah, and it becomes even more obvious when we do distributed computing that pushing uh, logic outside of the system that actually holds the data makes very little sense at times,
Mhm.
right? And this is again now going back to UX for a moment. UX in UX there's this thing called Tesla's law. You're familiar with Tesla's law?
No.
I believe that it's in UX. It's also relevant. That's true, but it's very relevant to also system design. And I started applying Tesla's law to designing interactions between systems. So in the 80s, there was Larry Tesler, and Tesler looked at the interaction of a human and a computer program. And the law is Tesla's law is the law of conservation of complexity,
Mhm.
right? So basically, Tesla described that okay, a problem domain always has the same inherent amount of complexity. Of course, we can overcomplicate it and add to it unnecessarily. True, which happens all the time, obviously. Uh, but then at that point, we also have who is going to handle that complexity. That's the key question, because the problem domain complexity is unchangeable, but we can divide it and handle it elsewhere. So that means that from Larry Tesla's perspective, that was an interaction of a human and a computer. Should we write more code so that the program handles the problem domain better and the user spends less time doing his work using the program? Or should we dump that complexity on the human for them to spend more time dealing with the problem domain, but we are writing less code? And the same applies to interactions between systems, to whom we're going to hand over the complexity of handling said data. It's very vivid in application integration and integration architecture, because if you introduce an integration platform between domain systems, you're literally giving away the complexity of handling interactions to the integration platform. So we're moving away the problem domain of interoperability into a dedicated system. That doesn't mean we're moving the whole complexity of interoperability to that system, because you still need to connect to the integration platform. But that also relates later to what is on the other side, what are the sources of data, what are the systems hosting the services we're using through the integration platform, and how do we handle complexity of those services. And sometimes, as a workaround or something, we're moving that complexity from the sources, from the provider systems, to the integration platform, or even to the consumers of the integration platform. This is in large ecosystems. In smaller ecosystems, that would be that the providers push that complexity away to the actual consumers instantly, because we have point-to-point, we have EDA, and that's direct communication. And then we have all sorts of forms of pathological coupling, right? So this is Larry Tesler, the law of conservation of complexity at play here. And I think we're basically subjected to this law every single day in distributed computing, whether we want it or not. We have to think about it. And this is also that shift left as a result of Tesla's law, because we need to think about that, where that complexity is handled. So we handle it as close to the source as possible. Then we need to think where to place that problem domain complexity specifically. Does that resonate with you in that sense?
Yeah, very much so. It's a really nice way of explaining it. Because I think, again, I don't want to derail the conversation too much, but when we talk about shift left, because we've got many other terms to discuss, there's kind of two things. One, if I just say, what you didn't understand what shift left was initially, it wasn't a term you're familiar with. If I say to a software engineering team who look after a service, I want to shift left all this complexity to you. I mean, like, well, why? That doesn't sound very much fun. So because what we're talking about today really is communication. How do I use the right terms to communicate the meaning of what I am trying to achieve to them? And how do I then explain the value to the overall company by moving this stuff left? I'm not just trying to make my job easier. I'm doing it because the outcomes are better and cheaper. So thinking of right terms to use there, of right analogies, or referencing Tesla's law is a good way of doing that. And the second thing is, when you're moving complexity from one place to another, it's what can you do to support them in their own quest of managing that complexity. So not just saying, okay, now you've got all this to deal with, but okay, now you have to do a bit more work here, but here's some tooling and platform capabilities that we provided to make it easier for you to do that. So we're asking you, for example, to take on better change management of data. And to do that, we'll provide you systems that allow you to catch schema changes early in your life cycle. So you're not able to push breaking changes downstream accidentally. And when you're making changes, you can be more deliberate about how you do that, and you can have a conversation about how you can roll it out and how you can migrate people and things like that. And provide them the right tooling that, one, enforces that, but two, enables them to manage that without having to become experts in schema management and change management and all the other stuff with data management, like GDPR and all stuff. There's loads of things that you can help with by providing the right tooling. So, it's supporting that complexity as well.
Or you place an integration platform in between and stop the blast radius of changes in the integration platform. That happens a lot as well. That's another way to handle it.
Exactly,
at least in operational flows, because in batch processing that's a little bit different. Okay, now we're somewhere in the beginning of the project, right? We're thinking about architecture. We know what data architecture is, integration architecture is, data integration is, or at least we have a understanding of it. But that understanding will be shifting right now because of how we think of data in the distributed world. So that is going to probably settle in the next few years to be more precise. Because we're moving away from those centralized, monolithic MDM solutions and thinking about data as one unified view, because that's a wet dream of somebody who thought this is feasible. So if we're talking about architectural approaches. Of course, one of those approaches is a class of software called MDM, so Master Data Management, right? For at least from data architecture. What other approaches we have in data architecture in terms of, I don't know, like we talk about software architectural styles defined by Mark Richards and Neil Ford in their books. Do we have something analogous to that in data architecture?
Yeah, I guess one of the bigger ones come out of the last few years is this idea of data mesh as an architectural pattern for describing how you want to create this more decentralized model of data integration.
Mm-hmm.
And for data mesh, for those who don't know what it is, it's based on these four principles of it's testing me now, of like data as a product, of self-service data platforms, of federated governance, data governance, and domain-owned data. I think it got a better name than that, but I've forgotten it. But really, what it's saying is, it's not a data mesh podcast, but what it's saying is, it's trying to describe what you need to do to enable a successful decentralized architecture, data architecture.
Okay.
So, and it's really a reaction to the issues we've had with centralized data architectures before, which we spoke about already.
Okay, so this is kind of in this regard, we're flipping literally binary from centralized to decentralized.
Yeah.
That's it. Okay. So from that perspective, in integration architecture, we have four architectural styles identified, and they're mostly dependent on scale, but also dependent on some other aspects of how things interact. So we have implicit architecture, usually consisting of mostly point-to-point connections, which at scale go into being a spaghetti architecture, as we call it. Then we have ecosystem event-driven architecture. So we're not looking at event-driven architecture to compose an individual domain system and to communicate components of such system, but to like literally communicate distinct domain systems through a message broker somewhere, or an event mesh, because that's also a thing. That's distributed messaging amongst many nodes. So analogous to the data mesh aspect. And then we have broker architecture, where we introduce a integration broker, and then we have API-led architecture, which is a evolution of service-oriented architecture, not the event-driven service-oriented architecture, but the orchestration-driven service-oriented architecture, and we add to the mix an integration platform in the form of an enterprise service bus.
Mhm.
Right? So these are kind of four stages of evolution of interoperability architecturally, and companies go through all of them to a certain extent, or make jumps depending on how bad they deal with implicit architecture. But sometimes you need more than one architectural style depending on what is the area you're working with. A common example is, for example, handling literal business data and machine data. If we have already a big company and we need to handle operational business data, that's usually API-led architecture, most likely. But if we're handling machine data, then we're handling it as event-driven architecture, and then finding a system within that event-driven architecture for machine data that collects that data, makes something meaningful out of it, and transmits this as a, for example, event to the API-led architecture, through API-led architecture to the rest of the business, right? So it's a matter of looking at this, at the scale, what we're doing, what's the data like, and what's the volatility of data, what's the volume of data, what are the time requirements of interactions, right?
Mhm.
So, and also the amount of distinct domain systems, right? Because if we have more than 20 domain systems, that's going to be extremely hard to make it into point-to-point communication, because that's already potentially quite a lot of pairs of connections, and each pair will have probably a multitude of distinct interactions between those systems. So that's growing exponentially, basically, right? And it's difficult to manage if you stay at a lower tier style. So that's this scope. So we're looking at basically at scale most of the times, some sort of a scale. And then the one thing that really popped sometime that was 2025 in Antwerp or the DDD Europe. Somebody from the Data Mesh conference came into our workshop, mine and Phillips, about and Thomas about integration architecture, and we were talking about all those architectural styles, and they said, "Oh, we're missing out on so much in terms of data movement because we weren't talking at all about ETL, ELT, and batch." I'm like, "Yes, we were. That's broker architecture." Integration brokers typically are, most of them originate from batch processing. So this is ETL, ELT, IBM quality stage, data stage, as technologies, for example, are typical brokers that are tailored for batch processing. Some brokers are tailored for single record processing, operation processing, but they are much rarer than those for batch processing. So think there's at this area there's already a bit of a friction in naming, because for you it's either distributed or centralized. For us, it's at the scale of what we're doing, and then we have distinct styles for processing certain things. So if we have batch processing, that's integration brokers. And that batch processing is named in several things, and I believe that the three terms that are used commonly is ELT, ETL, and batch. Simple, right?
Yeah. So ELT, well, so ETL first is extract, transform, and load. And again, it comes from what we used to do back in the day on those old sort of Oracle on-prem databases, where you would extract the data into some sort of transformation tool, do transformations there, and then load it into another database that would act as a data warehouse. ELT came a little bit later, more in the Hadoop era, when Hadoop came out, and suddenly we had access to Hadoop.
Hadoop.
Hadoop, yes.
Okay, yeah, I know Hadoop. Yes, okay. Misheard. They didn't understand. Okay, yeah, Hadoop.
Sorry,
yeah,
Hadoop.
that's fine.
So when you start getting these MapReduce frameworks, which Hadoop was an example of, when you started getting the ability to store large portions of data very cheaply, people decided, well, why are we just extracting some data, then transforming it, loading it? Why don't we just extract it all, and then load it into a data lake on HDFS, on file systems, and then transform it after? And they call that ELT, extract, load, and transform. And
so in this instance where we had ETL, that means the transformation process was actually in the integration broker handling the movement of data from from source to target, where in ELT the integration broker has no transformation capabilities whatsoever baked into it. It just moves data from one place to another. If anything, the transformation is at the level of fitting the data into the schema that is on the other side.
Yeah, exactly that. So yeah, exactly. Then the problem becomes, well, typically with ELT, you didn't really think about schemas at all until you try to load it. And then, yeah, you're trying to fit it into the schemas that you have in the data warehouse, where eventually it will go to power your BI tooling. And that's where a lot of problems were, because you paid so little attention to the extraction. You extract it all and chunked it into a data lake, you load it in there, and then you start trying to apply what they call schema on read. So, but data could be any format. You don't really know what it's going to be. It's probably changed over time, and we try and transform that into something that can actually be loaded at read time into the database. And unsurprisingly, looking back, that turned out to be a difficult problem, because you had all these data in a data lake of different schemas, of different quality. It's changed over time, not just schema, but meaning, and actually trying to write these MapReduce jobs in Hadoop or Apache Spark later, whatever you're using, was quite difficult, because you didn't understand data. The jobs became very complex, and one of these jobs wasn't easy, and they ran out of memory, and it became a bit of a nightmare. But despite that, ELT is still probably most widely used. It's people still load data, chuck it into a data lake, or maybe into one of more modern data warehouses where you can have sort of semi-structured data. And then you're still using transformation tools, but these days it's less, not Hadoop anymore, definitely. It's less Spark, less MapReduce, probably using something like DBT, which can then operate on your modern data warehouse, your BigQuery or Snowflake or whatever. The transformation's there in SQL-based language. And that solves a lot of problems we had with maintaining them, but not the problems we had with, again, trying to transform this data to something that's actually usable, that can actually be loaded into ultimately one table that can power a dashboard or could be table to power a dashboard.
Right.
The
So
same
so
sort of
this is
problems, but the
where
tooling has changed.
this is exactly where that shift left originates from, because people started noticing those centralized systems that quality of ingested data actually matters. So we should start
Yeah.
solving the quality of data as early as possible. So that literally means putting validation on forms where user inputs data into the system, right? Because that's the key. Because a lot of systems, for example, CRM data, was of poor quality because there were no restrictions on the forms how to input that data, or no guidance as to what is expected. So people just input whatever, and then that was something that was completely not manageable at the scale of millions of records. Because then every record was somewhat different, contained something different, because there was no validation whatsoever, no quality assurance as early as possible.
Yeah, exactly. That's a great example of shift left, because in that case, if you haven't captured the right input from the user at the data entry point, it's lost forever. You can never get it back potentially. So you have to shift left. The other tab you mentioned from your attendee at your workshop was batch, but I think batch is just more, both of the ELT and ETL are examples of batch processing. So
Yeah,
it's
it's
more
kind of an
generic
umbrella term.
umbrella
Yeah,
term. Yeah.
yeah. It's not. I never found it to be something on its own that's meaningful. It's usually that, oh yeah, we're processing large quantities of data, hundreds, thousands, millions of records at a time, and that's
Yeah.
basically what it meant. It doesn't. It didn't signify whether we're transforming anything or not. And then batch processing meant basically, yeah, either or,
Yeah, exactly. It's
pretty much.
not, yeah, you're right. It's not that useful term on its own. I guess it's kind of useful. People talk about in contrast to event processing, but even if you're streaming events, you might end up batching them together to do processing later anyway. So yeah, but not, yeah, technically they're not very useful terms, although people still use them quite a lot.
All right, so folks, stop using the term batch. Always be think about it and use ELT or ETL depending on whether you're doing transformation on in transit or not, and that is then meaningful. We have a very similar umbrella term in integration architecture, a little broader because it's more on the aspect of actual architecture of the solution. An integration platform, that's an umbrella term. Nowadays, an integration platform means either an integration broker or an enterprise service bus, which is very confusing because they represent completely different capabilities from a perspective of architecture. Enterprise service bus is more complex to build, but can deliver a lot better capabilities, especially in reusability, observability, extensibility of function. While integration brokers have less so, they're still very observable, but they usually are closer tied to a specific business process. Hence, like an ETL flow or ELT flow, it's usually very, very tightly coupled to what the business process is in this case. So that's another annoying umbrella term. I just recently started being annoyed by the term, and I was like, why am I annoyed by integration platforms? Oh, it's an umbrella term. That's why it's not
Yeah.
specific enough for my brain. But I used it for years, and now it's wrong in my head, and it's like I cannot. Speaking of platforms, uh, what's your definition of a platform here when you're dealing with in data architecture?
Oh, that's a good question. I really should have one because I do spend a lot of my time thinking about platforms. That's what I enjoy most. um, Me, a platform. And yeah, again, people talk about data platforms, they can mean all different things. They can mean the BI tool as a data platform, or they can mean something different. The terms I prefer come from ideas like platform engineering. Um, I can't remember the definitions people in platform engineering use off the top of my head, but when I think of a platform, it's a thing that provides capabilities to the users of platform to allow them to get their work done more easily. And
Hmm.
it does that through capabilities, through tooling, through automation. So, for example, say I am needing to manage some data. It's been stored at rest, I need to manage it. If I store that in a data platform and I describe the data well enough, because often we need to describe what the data is for a platform to be able to automate and for tooling to work. But as long as I provide the context for data and I store it in a platform following the standards, the guardrails that we have, then the platform can manage a lot of things for me, so I don't have to think about it. It can make sure the data is stored correctly, it's got backups, it's got personal data being deleted where it needs to be, it's got access management, it's got anonymization, it's all the hard things to do with data management. I want platform to take care of that, so I can just focus on providing data in this platform to my users. So
Okay.
that wasn't a really good one-line definition, but that's what when I think about platforms, it's that kind of capabilities that I want to be providing
I
to my users.
I think that Gregor Hope would definitely agree with your definition in that case. Looking at how he defines platforms, that's pretty much what it is. A platform should support capabilities, give capabilities, and then let users build on top of the platform whatever
Mm.
they need to make their work easier. From that perspective, if I look at the platform as an integration platform, whether it's a broker or an ESB, it's pretty much the same. I started looking at it from context of domain-driven design, where we divide things into subdomains. Right, we have the core subdomain, supporting, and generic. So a platform by itself is the generic being that's there, and it has no relevance to anything happening in the company. But the moment we start building integration flows on the platform, they become an element of the supporting domain, supporting the core business most of the times. But not only, also supporting the generic domain and the supporting domain, whatever those systems may be. For example, like an HRM system, LMS, these kind of things. Um, so again, it's a like you said, in that sense, it's a
Mhm.
capability to provide that application integration data movement that is tailored to the actual needs of whatever is the business process in this case. So the platform is a little bit, to that extent, a little bit more specialized, narrowly specialized, probably, because you probably have uh, quite significant more business logic on a data platform than you would have on an integration platform. And now
Yeah.
the key question: how do you define business logic?
Yeah, well, that's a good question because the platform, it might have some business logic in it. It might help you ensure that when you're producing, say, a customer record, the platform can help ensure that you're using a customer ID. And if you haven't got one, it can maybe provide capabilities to get you one.
Hmm.
And we do that so that if you're producing customer and another service is referring to customer, and a service in a different domain is referring to a customer, you can join them together and you can use the same customer ID. So it might have some business logic in that sense,
Hmm.
but often most of business logic will be written by the users of a data platform because they are providing the data that hopefully is meeting some business need. So they're having to produce some logic that takes the data they currently have and translates it into something that's useful for business, and that's where the logic is. So yeah, some business logic in the platform, but a lot of it is enabling others to provide that logic to their data.
But the main part of the logic is basically what users build on the platform rather than the
Yeah.
platform itself. All right. Now we have a different relationship to business logic as integration specialists. We absolutely hate business logic. That's a premise for all integration specialists. Absolutely do not like to have any business logic anywhere near an integration platform, whatever that may be, or integration flows. With the exception of ETL flows, which obviously have business logic because they're transforming something, they're creating something. But then we tend to leave the ETL flows to somebody else to deal with that, so that they actually know what they're doing within the specific business domain. Uh, the reason why we absolutely hate business logic is that we've seen time and time again business logic being pushed into an integration platform to be handled in the integration flows and then completely forgotten, which spectacularly resulted in all sorts of wonky production instance up to very severe outages. And that's the common problem of the space. Now, when I talk about business logic, and it's like, okay, what is business logic then in an integration platform? That's usually the key question I've been asked all over the place, and what you consider business logic. And from my perspective, business logic, and that's the easiest heuristic I found so far, is any kind of logic that takes data and creates something new out of said data. So I put this kind of a division. If I take data and create a new attribute out of it, we have business logic of sorts. This doesn't account for metadata of communication, because we obviously create metadata of communication everywhere, but that's normal because that's technical data that we use to navigate our integrations. But the moment we start meddling into the business payload of the communication, that becomes a problem, because that becomes a liability. Of course, while in point-to-point architecture, or well, implicit architecture, or event-driven architecture, well, we tend to see as a content-based router as an anti-pattern. In integration platforms, so broker and API-led architecture, content-based router is the norm. So we tend to take data from the payload and use it, for example, for routing purposes. And that's perfectly fine, because again, we're semantically not changing that data. We're just interpreting that data for the purpose of where the hell should we push that payload, right? Otherwise, we do integration logic, which is then defined as any sorts of transformation that doesn't semantically change data. So, for example, transforming from a JSON format to XML, or transforming from one data model to another. So we're just mapping the attributes one to one without changing the attributes, just pushing them into different placeholders in JSON, XML, whatever that may be, just that it reliably goes to where it's supposed to be. And this is not considered then business logic, it's considered integration logic, because every system nowadays with the distribution that we have has completely different data models and different contracts on top of that, right? So obviously we will not have one-to-one match, which means that we need to transform the payloads to a certain extent to match the target.
Mm-hmm.
Do you kind of feel like this kind of definition of a business logic makes sense here?
Yeah, that makes sense to me. I mean, it's a good definition. So as an example, let's say I've got a service
Mm-hmm.
that is providing like authorization tokens back and forth to its users, and I want to get that transformed into how active is this user, have I logged in for the last 30 days? Would that transformation be business logic being applied to that data in your definition?
So a service handles user logins, user.
So user logins, yeah. But I want to know how is this an active user? So have you logged in the last 30 days? That 30 days is a definition provided by business, right? That's what the business decided active means.
Okay,
So if
that
you
would
would,
be, if I would bake it into an integration platform, that would be considered business logic, just because it implies statefulness.
hmm.
because that means I would have to keep track of user logins. So I need to keep state. Integration platforms by default are supposed to be as stateless as possible. We cannot avoid state because it's impossible, because in transit we do have state. We have a temporary state on message brokers, on queues and topics, and we have caching. So this is state that we have, but we strive to limit the state exactly to that, and apply caching only when it's relevant, and apply state on queues and topics so that we have guaranteed delivery for asynchronous flows, but nothing else. Whenever the delivery is done, all data is erased instantly. Right? So we don't want to store data. We process data, but we don't want to store it, persist it anywhere. So in your example, we would have to persist user login information somewhere, where on an integration platform we don't have any space to persist that, which basically means that this would turn into business logic. On top of that, integration platforms usually do not handle users at all, because when we're integrating as an integration platform, we usually have a domain system and a domain system. And we want always by design to have user authentication and authorization handled in the domain system that is consuming the APIs of the integration platform, so that we exposing a service to a consuming system, we by design authorize that system to consume that service. But we don't deal with user-related traffic, because that's the role of that consuming system to handle its users. It's a very rare case where we actually transmit live user data from an actual front end somewhere else in the ecosystem. These are very, very niche cases where that user token or something like that is actually needed elsewhere. But that's usually something that is heavily encrypted, like a session token that is encrypted. Mostly when this happens, mostly when we build an integration platform in a large SaaS solution that is then later, for example, kind of built like micro frontends. So sometimes in these kind of cases, we do need to transmit user data, current session data, but this is a very niche case.
Makes sense. Yes, I think your definition, yeah, it works. It's good for me.
That said, so we're through idea, architecture. Now we're going down to specific projects. So if we're at the project level, well, projects from my perspective is I'm designing individual interactions between systems. Probably from your perspective as a data architect, you're designing what happens to data. So the so-called, from my perspective, what, where, and when, and some probably data also probably has behavior. That's what I'm guessing.
Yeah.
Okay. From my perspective, it's only behavior, because that's interactions of systems based on what solution architects or data architects give me in terms of that what, where, and when. Now, do we have any differences there in terms of looking at it? Because we definitely design different things, right? What is, in that sense, what kind of behavior do you have on data?
Lots, I think.
Okay.
Because I think, at least in my role, on all roles I've had really, but when we think about the projects that we do, some are just within the data teams, and it's how we are transforming data, and we're doing that to enable some new data application. So it might be a dashboard, it might be an ML model, an AI model, whatever, AI agent, whatever it is. But often, a lot of projects I get called into are not data projects as such. They are projects happening outside, and I am trying to work out how that is going to impact the data architecture and the how that's going to change what data comes from which service and how we're going to make sure that remains available to all other downstream systems. And therefore, I'm thinking
So
about how that behavior is changing in from those source systems, how that change in behavior of the source is impacting the data as it flows from there.
so that's basically, to a certain extent, we could call it change management of data.
Change management, yeah. I
Okay.
think ideally I would have to be less involved in those because ideally I shouldn't have to care too much how those systems are changing as long as they're producing data with right change management around it, and ideally not changing their data so much. So a bit like an API, it's relatively stable, and therefore they can do what they like because it has no impact on downstream users. And that's where
Okay.
we're trying to get to, or I'll be trying to get to a lot in data platforms I've worked on in the last 8 years or so. But often those abstractions are not always in place, and even if they are, they're leakier than I would like, and the change management isn't there, or the processes aren't there. So then I do spend quite a lot of time, and what I spent most of the day actually, in fact, doing is trying to work out how a change in one service is going to impact how the business is actually modeling data. And I'm trying to look at it from both sides. So I'm thinking you're changing the service in one way, but actually, does that even match? Does that even match how the business thinks about this data? Do they use the same terms? Do they understand it in the same way you're modeling it in your service? And at least
Hmm.
for what I'm working out today is there's a difference there. I'm trying to bridge a gap, to borrow a phrase.
So, so in this sense, then we come into modeling in terms of also modeling the domains and data domains and business domains cohesively, right?
Mhm. Yeah.
Because if we consider a data domain, that's well, I think that's, from my perspective, that would be the data models, the data that resides in a specific domain, and then business domain adds behavior, that's business processes, adds the aspect of when is that data created in a business process, when it's consumed in the business process, by whom, by which system, etc. Right? So that would
Mhm.
be kind of this notion. And then on top of that, somewhere in there between these two things is uh, the domain of interoperability, where we decide how those interactions happen when we know that this is supposed to happen now in the business process.
Yeah.
The kind of the placement there. Um, on the notion of domains, uh,
Mhm.
we both go to DDD Europe. Well, you'd go to Data Mesh that's hosted at DDD Europe with DDD Europe. Um, I know that 20 years ago the idea of the one view, the canonical data model, was a thing. I do not believe that serious data architects even considered canonical data models a canonical data model at this day and age, because we know it's a failure in scale. Um, but is there any difference in understanding what the domain is in data architecture than like what is described in domain-driven design?
Mm. Yeah, I'll be honest, I'm not particularly an expert in domain-driven design. Unfortunately, I've never been able to head into those kind of talks because I'm always at the Data Mesh Live ones, or I do a workshop sometimes there. So domain-driven design is something I want to learn, but I never have quite got around to. So I wouldn't know the differences. I imagine they're similar because I know, or I believe that domain-driven design was an influence for data mesh, and a lot of when people talk about domains in data, a lot of that inspiration is still from data mesh, even if they're not building a data mesh. But domains, trying to find domains is always a problem. So that's why I
Hmm.
want to learn about domain-driven design because it's always a struggle some ways it should be obvious, and sometimes it is. Like you'd have, if you're a payments company, then you have payments, and you'd have customers, and you'd have um, bank accounts and things like that potentially. Um, but then, yeah, I it's just an area I still need to learn much more about how we define domains
Okay,
because it's never quite cracked it yet.
so let's make it into a lot simpler question. From what I see, because apparently I've been using domain-driven design without knowing I'm using domain-driven design in integration architecture, and then now I understand that it was always there, but and started describing it in proper language. But how we tend to look at domains in integration architecture, especially when we reach API-led architecture, where we have explicit place where we can place domains, we can do domain partitioning, is that in each business domain, every object can be defined differently. So, for example, if I have, let's say, a order domain, like order fulfillment domain, and then the customer relations domain, both of those will have a definition of a customer.
Mhm.
And marketing domain will also have a definition of a customer. Those definitions will be different definitions in terms of the scope of attributes that data model will have for the object customer.
Mhm.
For example, if in a CRM system I'm gathering information about the customer, interactions with said customer that are attached to that customer, etc., marketing probably wouldn't care about the interactions, but they would very much care about the customer's birthday
Mhm.
and preferences. So already a different set of attributes. Then if I go to order fulfillment as a domain, the order fulfillment doesn't care about customers' preferences in terms of various products, in terms of communication media. They don't care about their birthday, but what they care about is their billing address, shipping address, and the customer's orders, which are another object, obviously. But the data of a customer originates in the CRM and then is redistributed to different domains, and then it shifts in terms of scope of data and it's mastered elsewhere for that specific domain. At least that's how I see domain partitioning and how different domain models for the same objects are used.
Mhm.
Does that kind of resonate with what's happening in terms of domains in data architecture?
Yeah, definitely. Yeah, exactly that. You where well, exactly described. Yeah. You want to you don't you want to have that flexibility. So within a domain, they can define the attributes they need to define, and they can manage those and take ownership of those. But then when you want to join data across domains, when you have that standardization there, that commonality there. Um, I I like to talk about it at these the kind of boundaries of ownership,
Mm-hmm.
and like it's when you're passing ownership of that data fro- from one team to another. That's where you want to start defining and agreeing on the definitions you're talking about. So if we're both if we're both sharing this customer record, or if this customer record is being provided from one team to another, that's where I want to make sure that we both mean customer in the same way. Up to that point, I'm less concerned about what you call a customer. Obviously, you tend to standardize, otherwise it's going to be confusing. But it's really those boundaries
Mm-hmm.
where I want it to be well defined.
Okay. But then you're looking at the boundary between different domains.
Yeah, in this sense,
Okay.
yeah.
So I have it a little bit more finer in integration architecture because I'm guessing you're looking more on a abstract level of a definition, semantic definition of what the customer is in that specific domain, as in understanding the data of a customer in that domain. While in integration architecture, we have another layer underneath because then we're mostly looking not at the semantic meaning of the data, but we're looking at the data model of the data. And even if we're still in the same business domain, like order or customer, the data will be expressed in domain systems that process within that same business domain. There will be bounded contexts that will have, each of which will have a different implementation of that customer object in terms of their actual data model expressed through OpenAPI spec, XSD, relational database, or whatever else. So usually when I'm looking at, okay, I'm building an understanding of what the customer is. I'm defining this with, if I'm working on an API-led architecture, I'm defining this in the integration platform interchange model. So we have our own domain interchange model for customer and for orders and for marketing and whatever, depending on the business. And then we're building an internal model, data model of the integration platform. And then we're always mapping from the models of other systems. So Salesforce will have their own wonky model with the __C. SAP will have their own wonky data model with German words abbreviated. Well, okay, fair enough. That's R3, not SAP for HANA, to be fair. But that's my memory of SAP. It's like I cannot even read it because it's German and abbreviated. So I have no idea what I'm reading. That's gibberish. So these are semantically, they're describing the same object from a perspective of understanding that object in that domain, but the technical implementation of that semantics is very different. So that's an additional layer lower that we as integration architects always dive into. And I think that was one of the misunderstandings we had last stream,
Yeah.
where we were talking about contracts. And I think this is a good segue into contract. But before we go there, how does this, like the data model aspect, translate to data architecture then?
Yeah, I think it translates well. But when you talk about data model, are you really, you mentioned maybe not semantics. So is it really the schema you're talking
Mm-hmm.
about? So
Yeah,
types, names?
implementation, literally. Yes.
Yes. And I think when we talk about data modeling in data architecture, we obviously care about schemas and the types, but we're also thinking a lot about the semantics and what does
Mm-hmm.
it actually mean? How does that model help a consumer or an agent to query that data to get the right answers for revenue numbers? So it doesn't matter what you do in your BI tool or what your agent does when it's trying to write your SQL and you're having a conversation with it, but you're still getting the same revenue numbers back because the data model has enough context encoded in it or with it in
Mm-hmm.
terms of semantics to ensure that you know what you're using and you can't get it wrong. So I think we go beyond just the schemas. We have to think about that as well.
Okay. Because to be an effective integration architect, we really don't have to go into the semantics of data. We don't really need to understand the semantics of data and the semantics of the business process that this data is involved in. It helps tremendously to understand the context and learn the business context. But integration architects is this kind of a profession that can remain for years completely agnostic of the business that they're embedded in. So if I am to be an effective integration architect, I really don't have to learn the business and still I can still remain effective. While most other architects will have to learn the semantics of the business, the context of the business to be very effective in that business. I just need to propose proper integration flows, interaction models that they can exchange data, but I don't really have to even dig into understanding the payload. Yet again, I will emphasize on this that it helps tremendously to actually understand the business and business process because it's an amazing shortcut to actually deliver quicker. But you can do without that. I think that's the only architecture profession where we touch the actual data, where you don't have to understand that data. Otherwise, of course, we have network architects, etc. Network architects don't have to understand the business at all. They just have to understand the infrastructure. And infrastructure architects, another example, but again, they are not really that involved in the overall business process. They provide a supporting service. Then if we talk about security architects, they need to be involved in data. They need to understand the severity, privacy of data to be able to secure it. So they're already involved, right, in the business process. So we're like in that position, we're unique. We can avoid understanding, but I really say we shouldn't. That's that. But we're looking at data models, and then we're composing something that we call a data mapping documents. So we basically, on one side of the data mapping document, we put the data model of a consumer. At the other side, we put the data model of the provider or multiple providers, depending on how complex the orchestration is in the integration platform. And then we try to mix and match and see, do those models match in terms of the scope of data that we need to transfer. And based on that, we build our own internal model of what the object should be. That's pretty much how it looks like in practice. So we don't have to build understanding. We just have to look and name it so that it's cohesive and enables the transfer of data. So we're really not looking that much at the semantics of the data, but we're looking at the actual implementation of contracts.
Makes sense. Yeah. I mean, I've joined my current role about 2.5 months ago. I actually changed companies as well, like about a year ago as well, 9 months ago. And really the hardest part is at the start trying to learn the whole business data models and what does that business actually mean. Even I work for quite a small company, you'd think the data isn't that complex, and yet the context is very specific to a company, and you have to learn that. You have to learn their semantics. You have to try and translate from the schemas currently in my case, but obviously we'll move away from this over time. Really the schemas in upstream NoSQL databases to, okay, what does a business mean when they talk about a customer or an account or a license and things like that, which are the things we're talking about. And that is, you can't, like, say your job will be a lot better if you do understand this, but for my job, it's impossible if you don't understand all of this, and it's really tricky. Or I find it tricky, at least.
Yeah, because you dabble more in the semantics than I do in that sense.
Yeah.
I'm very inquisitive, so I love learning about those semantics because there's always something interesting there. And if you dig deep enough into those semantics, that actually, for the example of my work currently, I started digging into the semantics of meaning of certain data, and I realized that the design of the data was flawed because it's not conveying meaning properly. So then from the perspective of interactions of systems, I can say, okay, we need to change this data to be transmitted differently or wrapped around differently because we're using wrappers, etc., because it doesn't convey the right meaning. So if I start understanding the business process, I can then actually make the interaction meaningful rather than just being CRUD. I really hate CRUD, and to not provide CRUD in integration, you really need to understand what you're doing, and this is where that business context really kicks in design. But if I were an integration developer, I really wouldn't need the whole business context. It would be a nice to have just to know that, oh, I'm making an impact on the world with the current company I'm working at, or a public institution, like in my case currently public entity in the Netherlands. It's an addition for most integration specialists, not exactly for architects, because then we can really pull additional information that influence the interactions, or we can suggest to change the design to make the interactions more efficient, so also change the handling of data and the design of data. But that's like really stepping into other roles, literally. But it influences our designs by that. We could make without it. Maybe the designs wouldn't be as efficient, but they will still perfectly work.
Yeah, makes sense.
And then I go into residuality by Barry Ryan, and then people go crazy if I start applying stressors at interactions between different systems. It's fun, extremely fun. Okay, but so now we're at the level of okay, we discussed domains. Now what we're at the level of, okay, we're designing something, some interaction. We have our data models and systems. We have our semantic understanding of the data in a domain. And now the most lovely part, we need to build a contract. Now, this is the place where we disagreed completely and had lost each other in the conversation last time. Andrew, what is a contract for you? Key question here.
Yeah, I hope I got a good answer for this one. So a contract is an agreement you've had between one party or one system and another party or system. And you have agreed like how this, for example, this data should flow from one to another. You've agreed what the schema would be, what the interface would be, what the SLOs would be, what the support level would be, and you codify that in a contract. And when you have this contract in place, you are no longer relying on assumptions on how data is integrated between one place and another. It's all there. It's codified. It's part of the platform. It's guaranteed to behave that way.
Okay.
So very much like an API contract, where again an API defines a contract of an API defines what you can expect to happen when you integrate with that API. A data contract defines the same for data, but includes a few other things because data has a few other things to manage with it as well.
In a contract, do you add things like the allowed use of data?
Yep, could do. In a
Okay.
data contract, you can add whatever you like, really, depending on what your use cases are. And yeah, allowed use of data is one. That would typically be for a human, I guess, to consume, but actually potentially as well for a platform to consume and prevent data from being integrated into a marketing tool if that person has opted out of marketing communications. That's potentially a platform guardrail you could put in. So yeah, anything you put in data contract, but I always say if you're going to put it in the data contract and make sure it's actually used for something, ideally by a platform.
Does this also mean that you in the contract you specify ownership of data and who can modify data?
Yeah. Yeah, ownership should always be in the contract. I think because all data should be owned, because if it's not owned, then who's responsible for it? So you definitely want data ownership in there. I'd say the only things you must have in a contract are ownership and the schema, because it's very hard to do anything without either of those. But then you can add anything, allows use, retention policies, access management, anonymization strategies, the length of your backups, like whatever you like really can go in there. But the minimum is a schema and ownership.
Okay, that's actually a lot of things that go into a contract.
Yeah, it's funny because when I first started with data contracts and came up with the idea of them, it really was about creating a better interface between services and data. And the reason why we called it data contract was because an API is like a contract between two services. I wanted something between a service and the data platform. But once we realized to have that contract, we needed something like an API spec, but for data. So we need to have ownership and schema at least. But then we realized, well, given that, we can then use the platform to create this interface. So an API is normally REST or similar, but you don't want to do that with data integration. You want some sort of streaming interface or batch interface. We're not supposed to say batch anymore, are we? But you want some sort of interface that is a boundary between the two systems. So we realized that we can use the platform to create that interface and manage that interface based on schema. And then we started thinking, well, now you've got data at rest here in this data warehouse, it's acting as your interface. Then we also can help you manage that data if you provide a bit more context around like data retention periods, for example, or backup periods or whatever it was. And we started adding more and more things to the data contract because of that, because it helped us provide the platform that automated and made it a lot easier to be a data owner. So yeah, it became this quite, I was going to say quite big thing, but it's not big. It just becomes a very useful pattern to use to help users manage data and help them provide the context and metadata of the data to the platform.
So I'm having a list of the things you mentioned. It's like, 12, 13 points at least. If I look at the aspect of how data flows, you mentioned that this is part of the contract. I always try to differentiate in a design this kind of high level of how data flows, and then the low level how it's actually executed technically. Because I find it that these are two different things. Do you get what I mean here, or?
Give me examples. So when you say how data flows, would that be like via an event bus or via Kafka or something? Would that be an example of how data flows? And then the other thing you said was how data is used. Is that right?
Yeah, but just on the flows, I differentiate of this high level view of data and how data flows through from systems to systems, and then I also go down a level and describe how it actually technically flows, what happens technically. So, for example, to make life simpler for certain people, the sequence diagrams I draft for how data flows is this system, integration platform, this system, done. Or if there are multiple systems involved, then of course multiple systems, and then in the sequence is shown what are the interactions through the integration platform. But the integration platform itself is just one swim line in the sequence diagram. While if I and then I tend to mark data flowing as synchronous or asynchronous without applying any nomenclature such as a REST resource URI or a queue name or topic name. These kind of things are, in this view, are non-existent. Then when I design the actual technical interaction between systems, then let's say some data is flowing as events from one system to another. So on the high level, it's just an open arrow without the filled-in arrowhead, like in UML sequence diagram standard, and it just goes to the integration platform, and the same arrow goes from the integration platform to the target system. We're doing event broadcast or just through a queue, one way point to point, doesn't matter. But then when I do it as a technical diagram, then I show that, okay, we're, as an integration platform, the principle for an integration platform, any integration platform, is that integration platforms conform to consuming and providing systems, right? So by that we also mean that an integration platform should be protocol agnostic, meaning that whatever protocol the consuming system prefers, we agree to. Whatever protocol the providing system exposes to us, we agree to. In that sense, the providing system is the one receiving the event, so to speak, and the the system consuming the integration platform is the one pushing the event. So in that sequence diagram that's very detailed, for example, we have the consuming system, the one producing an event, is actually producing that event to a JSON over HTTP endpoint, and it gets a HTTP 202 as a response, so accepted. And then the integration platform internally sends that message to a message broker to persist it on a queue or topic, and then distributes it to another component of the integration platform, which tries to deliver that message to the actual target system. So internally in the integration platform, it's asynchronous. Externally, it's fully synchronous most of the times. And on the sides, on the edges, it depends what protocol those systems prefer. So REST, JSON over HTTP, XML over HTTP. Oh, you want XML over JMS? No problem. Let's do this. Right? This kind of notion. So the flow of data is still asynchronous, but the actual execution is partially synchronous, partially asynchronous. The flow of data remains asynchronous by understanding how the data flows, executed differently. Now, for example, why we have synchronous endpoints for asynchronous flows is that here is the part of data quality, because we give a synchronous endpoint so that we can reject an event based on the quality of the payload. So we do on input, we do data validation against the schema. If the payload doesn't match the schema, then we can make a very restrictive schema with enumerations, restrictions, regular expressions, simple and complex data types. Then we just say, oh, sorry, some sort of a, what would that be? 400 error, right? Bad request, right? That is, I think that's 402 in HTTP, and we just reject it and send the error message back to the producing system. Hey, you screwed up. You do not adhere to the contract. That doesn't happen in event-driven architecture because the system producing an event just publish it to a message broker, and then it's picked up on the other side and then validated. You don't have any feedback at all, and we here providing these kind of quality gates for data quality so that nobody can push any bullshit in the payload. And same happens on the other side. If we try to push to a system consuming that event, well, they also validate and return to us. And then we have to handle it somehow. And then the messages, if not consumed, they drop to a dead letter queue. And then we have to handle that most likely manually to see what happened, why it wasn't delivered, etc. So, the level of details is actually very different. And then if I look at how it flows, there are completely two different abstractions of how it flows. And now the working joke between, for example, me and Philip, with whom I do workshops and teach people integration architecture and design of said integration architecture, is that if I look at the sequence diagram, would Jackie Reed scold me for that diagram? Right? Because there's too many abstraction levels on that diagram. That's why we have that split, because the flow of data does not one-to-one relate to the actual technical implementation of said flow. Right? Do you dive that deep into that technical, how it flows? Or is it something outside of the scope?
I usually do, because I am often trying to provide the platform capabilities, essentially the integration platform like you're talking about. Often the data platform that I've been building in the last few companies I've worked in has been providing these integration capabilities as well. So, for example, the most mature data platform I built around data contracts, we allow people to send data to, it was on Google Cloud, so Google Pub Sub, and then we had tooling that then archived that data to BigQuery, so it became available in batch processing as well. And that was a capability we provided to make it easy for people to send data to the data platform or to other software engineering teams as well via event-based, via PubSub.
Mm-hmm.
So I built that because I knew that was an integration pattern that we needed in the company, and therefore I needed to understand how data was going to flow to build a platform that provided the right capability to the company and that would actually be used. So I often do go to that level of detail. Obviously, I did not build an entire integration platform around it. It was quite a narrow use case,
In
but
this case, you
for
had the message broker, basically.
a message broker, yeah. But I had to get to that level of detail to provide the platform capabilities that would allow people to send data to their platform or send data in general to other data consumers. So yeah, I do have to go to that level of detail as well. And then in this example, the interface that I was talking about earlier, that is a BigQuery table or the pub subtopic. So you've got two different interfaces to consume data from, depending on your consumption model, the
Right.
event-based or the more batch-based.
But then, is it like from a perspective of a data platform? Um, does that mean like it's basically you're looking at the interfaces mostly rather than the actual flow of data?
Yeah, so I care about the interface. That's right. The interfaces are the pub subtopic in this case and the BigQuery table. Before it gets to pub sub and eventually BigQuery, that I care less about, and that was done in many different ways. Sometimes I did care about. Sometimes it was DBT jobs doing that, and as part of the data platform uh, capabilities we're providing, often allowed people to write DBT transformations more easily. But sometimes they are just quite big Ruby applications that had their own orchestration and were sending data themselves via PubSub and eventually to our PubSub. And those we didn't support so much. There's another platform supporting that. And we didn't care about that flow of data. So again, it's kind of that boundary of where the data is made available to the data platform so others can consume it. That's where we got interested and that's where we provided the interfaces.
Right. So then, basically, behind that boundary, it's where the integration architect picks it up to figure it out how it's supposed to be distributed amongst the rest of the ecosystem as needed, as
Yeah,
agreed with the data contract in that sense.
yeah,
So,
exactly. I mean, we did end up having our data contract infrastructure being used for internal movements within both services as well. They decided that actually we are using PubSub a lot and having schemas over PubSub that were managed with change management was actually quite useful as well for them. So they started using it there as well. But that's probably because we didn't have a better integration platform for them to use. So it's
mhm,
that or build something themselves. But that's not really what I designed for. I was really designing for getting data into the data platform.
right. At this point, I think it's very important to mention because we say interface a lot.
Hmm.
The modern notion of what an interface is or what an API is even more important. People tend to think API, they instantly jump to REST, which in fact is not REST, it's JSON over HTTP because it's not according to REST standards with metadata and all that, which is that web format, right? So I think it's important to acknowledge that when we mean interface or API, we do not specifically mean JSON over HTTP. We mean all sorts of various interfaces. Some of them may be a topic on a message broker or a queue on a message broker. That queue may be represented by JMS, AMQP, MQTT, SMF, all sorts of async protocols. On top of that, for synchronous protocols, we have SOAP, REST, JSON over HTTP, XML over HTTP, OData, GraphQL, JDBC is also a protocol here, and a variety of others. Very low level, very high level, to the extent that we're sometimes using literally network protocols rather than more sophisticated protocols built on top of those network protocols, right? probably your understanding of an API is pretty much the same at this point. That this is a variety of things, not limited to JSON over HTTP. So I think there we don't have a misunderstanding.
No, and it's a good point to make, actually, because another example of interface would be, let's say you're writing Python code and you're calling a library, you're calling the public interface to that library, public methods.
Yeah.
So interfaces are everywhere in software engineering. It's not just APIs.
And on different levels of abstractions, because in code in Java, you also have something called an interface, which is a different kind of interface than an API exposed by a system or application, right? It's like abstraction layers. The same word applies differently.
Exactly. But the key is that abstraction layer, that place that you know what you can call and you know what response you'll get and the shape of that response, and that you can have a contract around that interface. So very powerful idea, interfaces. I talk about them a lot.
Yeah, and now when we have an somewhat of a working view of what an API is, from my perspective as an integration architect, most contracts that I talk about are contracts that are implementable as a specific API. So implementation of a contract would be an open API spec, a WSDL file, async API specification, things like that, or literally a definition of a database function, stored procedure, a view, or a table. If I'm connecting from an integration platform directly to a database, which nowadays doesn't happen that often, luckily, that would be exactly the case. I mean, from my days back in the day when I was literally connecting to databases, I was like Oracle 9, Oracle 10 DBs. There are patterns for that to connect directly from an integration platform. Basically, you have a dedicated schema with a dedicated user that is a staging area that never touches production data. So that becomes your interface into that database. And then the database reaches out to that schema to pull that data into the actual production data, which is a safe way of building that interface. But if you expose your production tables, procedures directly to anybody, no, don't do that ever. So yes, luckily we don't connect to databases directly, but these would be types of implementation of a contract, literal implementation. And a higher abstraction of said contract would be a data mapping document where I have the definitions of the data model of one system, another system, and the model of an integration platform. And then I actually match those, say, okay, this is our contract, this is what we're moving to this side, this is the fields that we will be taking the attribute values from and pushing them to the other side. And that also consists of all sorts of metadata, as, for example, JMS headers, HTTP headers, that we could convey correlation IDs, message IDs, timestamps, these kind of things, alongside also defining what is the error handling. And then the error responses are defined as technical responses, but also business responses, because the communication may be done technically correct, so it's not a technical error, but the response from a service on the other end might be a business error. A business error saying, hey, there is no such customer, and a non-existent customer is not a technical error, it's a business error. That customer wasn't created, it's not there in the database, so we have a problem. You're trying to do something that is not possible. These kind of things. So we tend to, in those contracts, we tend to differentiate between what is a error of a business process and what is an actual technical error. Sometimes it's flattened down to HTTP codes, like business errors are often conveyed by 400 type codes. That's that. Or 500 type codes. I'm not a fan of that per se, but that works as well, if that's the standard practice in the company.
That makes sense. So the contract is, again, what you can expect to get back, and it will tell you what mistake you've made when calling the interface.
Yeah.
Yeah.
So that defines the structure of input data, the structure of output data, um, hopefully relationships between different attributes when they come optional or not. So I always don't like very flat structures with optional attributes, because that's usually a smell that between those attributes there are hidden relationships that create a form of pathological coupling that I suddenly need to know what is the processing of that system on the other side to actually make those attributes work. If that's a tree-like structure where an embedded object in the base level is optional, then I know that every attribute in that object is then also optional from that perspective. But when I add this object, I need to fill in specific attributes, etc. So all of these are part of that contract, so that I understand the behavior of the structure of data and what attributes of data need to exist in the communication, rather than what is the semantic meaning of said data. Again, we don't really look at the semantic meaning in transit, because we don't want to. We don't want to store, process the payloads, because we don't want to build the business logic based on those payloads, right? So in that sense, maybe that's wrong, but we usually don't have SLAs. We don't have anything related to who's allowed to use it. We don't have any guardrails other than actual error handling. We don't discuss ownership in integration contracts. Those things are usually described in the solution architecture. So two abstraction levels above what we do in an integration contract. We do describe sometimes policies, but those policies again are low-level policies like security policies, throttling policies, rate limiting policies, and those policies become the SLA, especially if that API is exposed externally to external consumers. For integration platforms, that is very rare, but for productized APIs, that's quite common, and that is basically when we define APIs on the level of a system. That's pretty much what it is. So that abstraction level of a contract is probably very different in that sense.
So, is there any reason why an integration platform shouldn't care about things like SLOs, and why it couldn't help to monitor those and enforce, send alerts automatically? Because it knows when, I guess it does, or maybe it doesn't. Like when I'm thinking about data platforms, the reason why we put things like SLOs in there, because it's quite easy for us to monitor them in the platform. Because we can see, as long as all data has, say, a create that field, we can compare the time we saw that from the time it says, and say, oh, actually, it's taken an hour for your record to get to us, when actually
Yeah.
you said it'll be there every 5 minutes. So that's breach your SLO. We can send an alert to the owner, because we have the owner in contract too, and we can do that in contract level. So as a data producer and a data consumer, you know that that contract is being enforced, you know when alerts happen, you can, it's all done for you. You don't have to think about that. You just
Right.
define what you want. I guess
So
in an integration platform, you mentioned you have metadata sometimes available
yeah,
to you that you can use for routing and things like that.
yeah.
Could it also do things like this then?
Uh, that's not precisely in the scope of an integration platform. Well, it depends. It can be. Um, Depending on the technology, we have different capabilities embedded in technologies, which makes it more problematic, because from technology to technology, those alerting, monitoring capabilities very differ. Uh, so we always try to embed in every integration flow logging and monitoring. Monitoring is usually externalized outside of the integration platform technology. So we're having like Logstash, etc. Kibana, Grafana, whatever that may be, and then through logs being fed in real time to set tools, and there we can create alerting, another capability is to say, hey, something's wrong in the process. And then we also create those rules based on some SLAs that were provided in the solution architecture. But that's stemming from the end-to-end solution architecture rather than from integration contracts per se. And it's to a large extent usually externalized. The tools that are provided by integration vendors, middleware vendors, they differ drastically between one another depending on the licenses we buy, because there are different licenses tiers, so different deployment models. So sometimes we have tools available, other times we don't have tools available, which means that for the most part, it's more feasible that we build these tools ourselves, and we have like a centralized organization-wide logging and monitoring tool. So then we build those integration dashboards there and create set alerts if we have if we have these kind of the requirements. The problem is we usually don't. That's the painful part. We would love to have them, but we don't. Now, this is where that part of actually semantically understanding what the hell is going on in the business process kicks in, because then if I understand what the business process is, then I can design those alerts specifically to actually work. But I have to know what is the behavior end to end, and this requires more involvement of an integration architect and an earlier involvement of the integration architect in the design process. That's the difference. Of course, if you're on the data platform, which has also a different function in that sense, and we're working on data, you probably already have tools for set alerts when working on data, while here we have to kind of be a little bit more inventive, because the types of alerts we may encounter in integration will be very, very, very different.
Interesting.
Now, given the time, we've been at it over 2 hours already, and I think we still haven't covered parts of it. And I think the chunkiest parts that we haven't covered is anything related to governance. I think, Andrew, we'll have to do governance another time. What do you think?
But yeah, unless we can do it in 5 minutes or so.
I don't think we can do it in 5 minutes.
It's a bit big, isn't it? Okay.
It's a chunky part. I think we should have a completely separate session on just talking about governance and figuring out. Ooh.
Oh, yeah.
Lights went off.
Yeah, I'm in a shared office, and apparently someone turned the lights out.
They're pushing you out. Okay, we get this.
That's probably a sign. But I have to come back a third time to talk about governance.
Let's do this. Okay. So, given the time, given that we covered quite a lot, right? We covered from just to summarize, we covered from the inception of an idea of what we want to do, through the design process of architecture, through the design process of using data, interacting between systems, and going a little bit into operationalization of that data. Now, I think the aspects of governance that we have is the general data governance, integration governance, API governance, and then productization of APIs and data. I think this falls under governance as well. We can cover another time in that sense. I think it would be a nice continuation of the conversation, because I think there's plenty there to discover.
Definitely.
Sounds good? Before we move on, next week, 30th of July. Now, please don't butcher the name. Please don't butcher the name. Please don't butcher the name. Xin Yao, a socio-technical architect and change facilitator, is going to be the next guest on Loosely Coupled, and we're going to be talking about identity as architecture. So rethinking, pretty much everything in the age of AI. That pretty much AI makes us rethink a lot of things nowadays, right? And so join for that. That's going to be a very interesting conversation next week. On top of that, of course, if you manage to stay with us to this lovely late hour, any upcoming events, articles, previous sessions, previous Loosely Coupled episodes, all of those are available at bridgingthegap.eu.com. Also, a reminder, where Philip and I were running strategic integration design with DPD. Current session that is planned at Avans Coperta. So this is a QR where you can visit, check out the the conspect of the training, see if that it matches your need in terms of learning about integration architecture and design. And lastly, please do subscribe, if you will, to the YouTube channel to get notifications about the live streams. Of course, I also distribute these on LinkedIn and on the website, so plenty of places to learn about those. But YouTube probably is the quickest. Always nice to see the numbers rise. But of course, if you don't want to, hey, heck, I do this for fun. That said, for the fun of it, Andrew, thank you for making my evening so fun with this conversation. That was a good conversation. We didn't have that many disagreements here because we were actually focusing on avoiding them and explaining. So that was a very nice session of building a mutual understanding of how we understand terms. I think there was plenty of terms that we covered very sufficiently over the last 2 hours. So thank you very much for joining, and then hopefully we will be able to schedule a next session just to cover the chunky parts of how we govern the aspects of data and integration architecture. So